Hello, my name is Andrew Miller. I have a little presentation here on the backup system that I designed to support my medical equipment. With the help of my great friend Dan, this system is built and up and running. The name PriHaus comes from the fact that my system is hybrid, like a Prius, for a house. The reason why I pursued a backup power system was primarily for a medical need. I am ventilator dependent, and along with the ventilator there are several other pieces of equipment used to manage my health that rely on electric power. Secondly, I did not want my caregivers to be burdened with the emergency that would occur with a power outage. And last, because the control of my environment at home is so reliant on my home network, it needs to remain up and running. So in my eyes, the perfect system would first meet my medical need. This means all the equipment I need to live would be supported. Also, to aid in both my comfort as well as that of my caregiver, the system should support some comfort items such as the home automation system, refrigeration, home heating, etc. On the topic of performance, this system should require little to no interaction for long periods of time. That means there is a battery in this system and it would support normal home operation for several hours. When an outage is long enough to deplete the battery, the duration of which a generator must be run to recharge the system should remain short. If we look at power sources at both ends of the spectrum to meet my requirements, there are many inexpensive portable battery systems on the market today. The challenge here is that they take many more hours to charge than they last as a power source. While they will easily support a few 120-volt items, they are more difficult to use for home heating and refrigeration. On the other side of the spectrum, whole house systems support everything. They are typically very expensive to install and require regular maintenance. So the goal should be somewhere in between. I had a strong interest in the final system being a hybrid of these two extremes. It would use both batteries and generator to supply power. Before I determined the power source details, I reviewed backup power items for and what circuits in the main circuit panel those items were currently on. Lucky for me, all of the medical items are on circuits in my first floor bedroom. The comfort items were more difficult, but in the end circuits were determined. As part of the final design, all of the circuits here were moved from the main circuit panel into a separate circuit panel to isolate them for backup. This separate panel is typically called a sub-panel. So after a lot of research, here is the basic system design I came up with. System components are installed directly next to the home main circuit box. The demand of the circuits in the sub-panel is supported by the output from the inverter charger, in the middle of the slide. In the event of a power outage, this device takes energy stored in the battery to support the demand of the sub-panel. The inverter charger also has power input. When this exists, it passes through the inverter charger to support the demand of sub-panel. In the event that the battery is below 100%, additional input power is used to charge the battery. The transfer switch allows the source of the input power to the inverter charger to be either the electrical grid or a portable generator. Under normal circumstances, the switch is set to the grid position. During a power outage, when the battery has been drawn down to a low state, the transfer switch can be set to generator. When the generator is running, it will support the sub-panel and charge the battery simultaneously. Once the battery is fully charged, the generator can be shut down. This is my system as installed adjacent to the main circuit panel. The battery is in a metal case on the floor just below. Note that I added a system monitor. The system monitor allowed me to record system variables while in use. When the system was operational, we performed an intentional power outage. Operating solely on the battery, the system ran for 10+ hours. At 30% battery capacity, the portable generator was started and connected. It then took 2 hours to bring the battery back up to 100%. So out of 12+ hours of a power outage, the generator only ran for 2 hours. We have yet to have a real power outage and understand the true system performance. I have several ways to monitor the system. In my eyegaze application, I have added a view into the website that the system monitor supply. There I can see current system status. I have also integrated it into my home automation system and can display a similar current status view. Currently, I have automated an alarm that lets those in the house when it is time to start the generator based on battery status.